In the last step, we have to integrate this new interface for expression trees into our parser for the calculator. And here we have to come up with some approach so that we do not end up with pages of error messages. And I want to show you my idea how to do this step by step. It will not go without error messages, but it should be as painless as possible. In our small project, it will actually not be that hard. We just have a few functions, the parse functions, where the interface will change. Instead of returning a double, it will return a pointer to an expression node. And these functions will no longer receive a parameter for the indent. This was only required for this debug code. And then, of course, we also have to change the implementation of all these functions. We should get rid of this debug code, and instead of computing values, we simply should call this constructors for generating these expression nodes. So that's basically it. But if you forget a few things, then you easily end up with this pages of error messages, and then it's sometimes frustrating. So let's get started and show you how I do this step by step. So that's the code for the calculator after the last quiz. And first of all, I want to get rid of all the debugging code, and then I want to reach a point where it's still working, just without debugging code. So that means I already can get rid of these parameters for the indent. So then I'm already closer to the declaration how it should be in the end. I still will compute values and return a double in some parse functions. So basically you can search for indent and then change everywhere the places where you have this indent. And even if you forget some place, in the end you just search for indent. And anyway, the first step is just getting rid of the debug code, and this will not generate lots of error messages if you forget a few things. But making all changes in one sweep usually ends up in a mess. That's my point. Here is another one, and here we need void, and here we again can delete complete lines. I'll change that later. And now I search for the remaining identifiers, indent identifiers, and that's it. And now I try to compile. Okay, so this is an error message because I now have to call this parse input sequence without a parameter. Okay, but now I'm back at a working program, just without this debug code. And now the next step will be to actually use this new data structure. So I include it, and then I change the declarations for this parse functions that do return some pointer to an expression node. But I will not implement most of them. I just will implement the last, the parse factor function with the new interface. And the remaining functions will be undefined. So that means if I compile things, I will get linker errors. But I can make sure that I have the implementation of parse function mostly correct. So this here now changes so that I again have an unsigned integer. So now here I generate a primary expression node, and the same thing I have to do for this two other cases where I have a literal. And then here I also have to change this. So this is now a pointer to an expression node, and this pointer should be returned in the end. And this will generate a linker error because this parse expression function is not implemented currently. And here I just return a null pointer. Okay, but that's it. And then I here maybe just call this call parse parse vector and print the expression tree in the end. But this will not compile into an executable anyway. Here is the link error. But that was expected, and still I now know that in this implementation of parse vector most things will be right, and now I work my way up in the food chain. So here again this is a pointer to an expression node. And then here I actually also want to return a unary expression if I have a unary plus. So here I just use directly a return for this unary minus node, actually ek unary minus. And otherwise I have this unary plus, and this will also generate a new node so that I can see in the expression tree what actually was passed. Okay, and this will give us another linker error, but no other error messages. And as long as I just have linker errors, I'm happy. And then here basically the same play. Every val becomes expression. So val becomes expression, and val right becomes expression right. And now here, instead of computing the power, I use the constructor for a binary expression. So expression becomes a new binary expression node with this expression kind for the power operator, and the left side is the old expression, the pointer to the old expression node, and so basically the same as before. Just instead of computing something, you use it as parameters for the constructor. And so this also works. And then always the same pattern. So this becomes a expression right pointer. And instead of computing something, we generate a new binary expression node. And here we just have to change the kind. And of course the return value. And then again, this becomes the expression pointer. This becomes a expression right pointer. And here I now just have to delete these 2 lines and change this expression kind. Okay, and okay, this was forgotten, but you see, you only have a few errors, so, and whenever you have more than just a link error, you fix them immediately. And now we're completely rid of all the problems. These functions actually have not changed the interface. We just have to change here the implementation. We now get back here some expression node and no longer a double. So instead of printing the value directly, we have to use this eval expression function applied to this node. And then we can print out the value that was in the expression. So this was actually not needed. Okay, now we can check it if it's still able to do some important computations. Okay, seems to work. And then of course we now can change the output. So instead of printing the value, we want to print this LaTeX code. Okay, and this could be now redirected into a file, and then we can use LaTeX again. And now we finally have what I showed you in the first video in the beginning. You can use echo with some arbitrary complex expression and automize this complete process. And we have hopefully a nice PDF for this. Okay, so this is actually a fix that we should have encountered before in the test cases, but we haven't tested the power function. The problem is in the LaTeX code, this \hat is only allowed in the math mode, so we have to put this between 2 dollar signs. So this is something that should have been detected in the test suite before, but still just one minor fix. And now this is hopefully now working. Okay, so that's it. And then you can play around with that so that you also have these circles around it.